Welcome to the Introduction to Xpediter CICS module. Here you will learn about the basic functionality of Xpediter CICS and how the most common commands are used to address an abend situation. Xpediter CICS is a testing, debugging, and analysis tool that enables viewing source code as it executes. This may be used to identify incorrect logic, to test hard-to-validate routines, to analyze program structure, to analyze program flow, and to troubleshoot abends. During an Xpediter session, the user may control program execution, display or modify program variable values, intercept abends, monitor execution coverage, alter program execution, and review program execution. We will be going through a sample program where the user controls Xpediter, which in turn controls the program. The program name, transaction code, and file name are shown in the diagram. 4 main command types will be used. Go commands cause program execution. Breakpoints pause program execution and return control to the user. Keep and peek commands examine working storage and display current values. Show commands examine user controls in place, such as where breakpoints have been set. These brief descriptions will be sufficient to understand the sample debugging session, and the commands are described in more detail later in the module. We begin by entering the tran code to launch a demo program. Entering one of the employee numbers shown causes the program to react as described in the comments. We will choose the last option and allow the program to end normally. The result is shown here. We now re-enter the tran code for the demo program, this time choosing the employee number that will cause an asra abend. As expected, the transaction fails with an asra, but little else is known. We need to get some help from Xpediter. We enter the tran code for Xpediter, which is normally XPED. This turns on Xpediter for this terminal only. When the Xpediter primary menu appears, we clear the screen and enter the tran code for the demo program. Then, as before, we enter the employee number that causes the asra. The result is remarkably different. We are viewing the source listing for the demo program. The message indicates that the asra is a data exception and it occurred at statement 426. That statement is highlighted. The keep window contains the 3 program variables used in that statement, and their current values are shown. The red characters denote the invalid data. Wow, thanks Xpediter. I already know a lot about the problem and I haven't done any work. Let's fix the problem and get this program rolling. This is a payroll application, and this employee's hours worked value is invalid. We overtype the value shown, then press enter. The color change from red to green confirms that the new value is valid. Next, we enter the go1 command to execute the current statement. We see that the statement was executed without incident, and we are positioned at the next statement. we enter another go1 command. Again, the statement is executed and we are positioned at the next statement. Finally, we enter a go command and the transaction completes successfully. We are not really finished. Let's roll up our sleeves and dig in and determine the cause of the asra. To proceed, we enter the tran code for Xpediter and specify the module name to display the source listing. Note that your initial view of the listing depends on the previous point where Xpediter was involved. If the program had never run, or had run to completion successfully, the initial view would be at the beginning of the procedure division as shown here. In our case, the program abended in paragraph 300, so the view is positioned there. We set a before conditional breakpoint to pause the execution before the compute statement, but only when a specified condition is met. We see a confirmation message and a new line and the word if are added. All we have to do is provide the condition as shown. Pressing enter changes the characters to uppercase and adds the text prefix to the string. Next, we set a breakpoint to stop execution before the first executable statement in the program. Here we see the confirmation message. At this point, only 2 breakpoints have been set. In other situations, numerous breakpoints are commonly set. To conveniently view all active breakpoints, use the show breaks command. The display is changed to exclude all source lines except those with breakpoints. The reset command redisplays the excluded lines. We will do one last thing before proceeding, and that is put the WA hours program variable in the keep window to observe its value as the program runs. Here we see the message confirming that the keep has been set. Now it's time to get down and dirty and run through that transaction with control of the program. Remember, Xpediter is still running, so we just have to launch our program. We stop at the first executable statement in the program as a result of the before 0 command set earlier. The variable WA hours is displayed in the keep window. It does not contain a value at this time. We enter a go command and again cause the asra. Re-entering the program code, we use a when command, another type of breakpoint. Execution will stop when the value in WA hours changes. This will help determine the source of the bad data. A go command restarts program execution and it halts because of the when command. There are 3 variables in the keep window, 1 because of the keep command and 2 because they appear in the current statement. WA hours now contains a value, a bad value. This has resulted because of the move statement on line 406. We are advised that we are stopped after statement 406 has been executed by the message and by the double arrowhead. Next, we do a little exploring. Overtyping the K in the keep window with an H will display the data value in hex as shown. Next, we note that WA hours changed and therefore received the bad data with the move statement. This implies that the group variable payroll data emp01 is the source. We can peek at that variable by prefixing its line in the keep window with a P. Alternatively, we could use the P and peek primary commands as shown. That, of course, would require keying in the variable name. Here we see the result, including the bad data. We can correct that here by overtyping. To return to the source listing screen, to execute the statement again, this time with valid data, we press F3. We now need to alter the program flow by repositioning the execution pointer to the previous line. We do this with the goto line command shown GT on line 405. Alternatively, the primary command shown could have been used. We see the confirmation message and the execution pointer has been moved. Next, we enter a go1 command. The value is still bad because the move has not yet been executed. Another go1 is entered. This time the value changes because the move is now complete. Everything should be good now, so we enter a go command and the transaction completes successfully. This example is now complete as well. When your Xpediter session work is complete, there are two Xpediter termination options. The XPND transcode is available, or the system menu may be used. We will look at both. After clearing the screen, entering the XPND transcode shown here will terminate the session and display a message similar to the one shown here. From within Xpediter, choosing option X from the primary menu, or alternatively, using the jump command from another panel will display the exit session menu. One need only overtype the first character with Y to terminate the session. At this point, several options are available. You may click on any of the green buttons to learn more about commands introduced in the example. You may click on the blue buttons to learn about two new basic commands, or you may exit this module. As a reminder, you may also use the navigation panel to the left. The go command resumes execution and follows any specified parameters. Two variations were seen in the example, go1 and go. Other variations include go, followed by a number other than 1, such as go5, go until some variable changes in value, and go until followed by a variable, an operator, and a value. The permissible operators are shown. Here is a bit more information about the unconditional go command. Execution will resume and continue until a breakpoint is encountered, the transaction completes, or the program crashes. Please keep in mind that all of the options and all of the parameters of the command shown in this module have not. Breakpoints pause program execution and return control to the user. In the example, a before zero primary command was shown, along with a before conditional line command, followed by completing the condition. Here you see that either a primary command or a line command may be used to set a before breakpoint. Similarly, either a primary command or a line command may be used to set an after breakpoint. Here is a case where an after breakpoint is already set. We add a before breakpoint on the same statement, and the resulting marker is the @ sign. A one-time breakpoint, as the name implies, is a temporary before breakpoint. When reached, it is automatically deleted. It may be set with a primary command or as a line command. The resulting marker is the letter O. Here are three additional examples. After all CICS receive sets multiple after breakpoints. Before all paragraphs sets multiple before breakpoints. And run to 425 sets a one-time breakpoint and executes a go command. The when command was introduced in the example as another type of conditional breakpoint. Recall that when WA hours is the same as when WA hours changes. The when may be used with an operator, as shown here. Also, compound conditions may be used. Here you see the list of permissible operators. The keep command displays the contents of a data item in the keep window. To change the displayed value, overtype with a new value. In the example, keep WA hours, a primary command was used. The resulting keep window is shown. Here we see three variations of the keep line command. K keeps the first variable on the line. K may be followed by a number. Here, K3 keeps the third variable from the left on the line. K asterisk keeps all of the variables on the line. The show command excludes all source statements except those specified in the command parameter. The abbreviated form is sh. In the example, the show breaks command was used. Here we see that show afters may be specified in three ways. The same holds for show befores. The last three examples illustrate show one time, show keeps, and show when. The delete command is used to delete breakpoints, keeps, and whens activated in a program. In this example, a keep has been set on a program variable. We overtype the K with a D, then press Enter. The confirmation message is shown. In this example, show keeps was used, revealing that 3 keeps had been set. Either the delete primary command or the delete line command may be used. Here, the show when screen indicates that one when condition is in effect. The D line command may be used to deactivate that condition. These 3 examples illustrate how to delete multiple breakpoints with a single command. In the last delete example, several before breakpoints have been set. They may easily be removed with the block delete line command. The set command allows changing debugging session parameters. This example begins in a familiar situation. The program is paused when an asra occurred. Upon entering Set Keep Off, the keep window is removed, allowing for more program source to display. Set Foot Keys is now entered, and the PF key settings are displayed at the bottom of the screen. Set Foot Off removes that information, and Set Keep 5 redisplays the keep window sized at 5 lines. Please keep in mind that all of the options and all of the parameters of the command shown in this module have not been included. Attempting to present that information most likely would have led to undesirable results. In addition to viewing the other Xpediter CICS modules available here, you are encouraged to download from Frontline the full reference manual and his little brother, the Quick Ref. Also available are the language-specific user guides. COBOL is shown here, and comparable guides are available for Assembler, PL1, and C. We hope that you are excited about the capabilities of Xpediter and are eager to use it to help solve your problems. We think you will agree that it's really a cool tool. This concludes this module. Thank you.